Hey everyone, in this example, we are going to find the area of the shaded region in the indicated picture. So in this particular picture, we have two rectangles. We have a gray rectangle and a white rectangle within it. So in a situation like this, what you need to do is just some simple algebra and geometry. So we're going to do the area of the larger rectangle minus the area of the smaller rectangle, and that's going to leave us with the area of the shaded region. So we'll write it like this. So this is sort of our formula. Now these two are rectangles, right? So draw a little rectangle, and then we'll be left with the shaded like that right there. Okay, so to indicate what we're doing, the capital area obviously is the bigger one in my little notation here, and the lowercase area is the smaller rectangle, right? So what is the area of a rectangle formula? Hopefully we all know that formula to be, whether you consider it length times width or you consider it base times height, it's the same thing, right? So area of a rectangle can be considered either of those things. Now, the image was kind enough to put parentheses around the binomials that are describing the lengths. Make sure if they're not there that you put them there as well, because when you're multiplying a binomial by another binomial, if those parentheses aren't there, you're more likely to make some mistakes, right? So we're going to go ahead and fill in base times height of this big guy and base times height or length times width of the smaller guy. So I'm going to start off here with 4x minus 5 times 2x plus 3, and then we'll subtract once we do that, and we'll do the other one, which is 3x plus 2 in this situation, and x minus 8. We're all set up, ready to go. Now we're going to go ahead and use FOIL to figure out each of these areas, and then we'll still be subtracting. Now, because I have this minus sign, as you'll see in the next example as well, we are going to keep parentheses here. If it was addition, if you are adding these areas for some reason, the parentheses wouldn't be necessary, but since minus means you're adding a negative, and negative means opposite, parentheses are necessary. All right, so FOIL, first, outer, inner, last, our mnemonic device for multiplying binomial times another binomial. So when I am multiplying first times first, this is comparing those two terms right there. When we do outer, we are looking at those right there. When we are looking at inner, make the eye like that, we're looking at those two terms right there. And we are looking at last, we are looking at those right there. Hopefully everybody knows what I'm talking about. And if you're at a point where you're reviewing for your algebra midterm and now you finally understand what FOIL is, I'm very happy for you. Better late than never. So first times first gives you 8x. Now really keep in mind those are both x to the first. So when you multiply, you add your exponents on your variable right there. X to the second. Outer is really 12x. Inner is negative 10x. Last times last is negative 15. Again, I don't need parentheses around this because I don't have a minus in front of it. Over here, first times first, 3x squared. Outer is minus 24x. I see a lot of people do 3 times 8 is 21. That's 3 times 7. Make yourself flashcards. Plus 2x minus 16. So there we are. I'm going to combine like terms before I move on. 8x squared, this will be plus 2x minus 15 minus, let's keep the parentheses just for a moment, 3x squared. Negative 24 plus 2 is negative 2x. What am I doing? I don't need to close my parenthesis yet. And then minus 16 is still there. So let me just fix that. I got a little too excited about the parenthesis, I guess. Oh God, ruining this whiteout over here. Sorry guys. I don't want to give you, oh no, this is, jeez Louise. All right, there we go. Sorry. Minus 16 So now let's show you what this looks like when you distribute that negative. And you'll see this again in the next example as well. But 8x squared plus 2x minus 15. This is going to be a minus 3x squared. I'm going to write it vertical or under the other squared term. So the quadratic terms are lined up in a column. Then this is minus a negative 2, so it becomes plus 2x. It's going to go right there. And then minus negative 16 will become plus 16. That will go right there. I draw a line to show myself, this is where I'm setting up my next step. This right here, adding and subtracting is counting. Nothing about the x or the x squared changes. You're counting how many x squareds you have, how many x's you have. Adding and subtracting is counting. You don't change the thing you're counting. If you're adding radical 3, 5 radical 3 minus 2 radical 3, it equals 3 radical 3. The radical 3 doesn't change, okay? Just like bananas. 5 bananas minus 2 bananas, 3 bananas. So this here is 5x squared. You're adding, so you have 4 x's now, and then negative 15 plus 16 is plus 1. So there you go. There you have it. That right there is a quadratic trinomial, and that represents the area of the shaded region. I don't know if I'm fitting this on here. There we go. Just barely. All right. So I hope you found that helpful. I hope you understood what was going on in this example. And if this was good for you, put a thumbs up. And if it wasn't, go ahead, put a thumbs down. Doesn't hurt my feelings. Click through to see the next example in this Algebra 2 midterm review. And I hope you're doing great. Adios.